We'll take a look at a single example here, but we'll move through this process relatively slowly. Um, if definite integrals are fresh in your mind, this really won't be overly a complicated process, but it is a little bit different looking at first. But really what's going to happen is we're going to evaluate a definite integral once. That will generate essentially a new function, and we'll find a definite integral a second time. Before we dive into that process, we'll just point out that there are two different approaches that you could use to solve this problem. The way it's written is that we're being told first to integrate with respect to y, then with respect to x. We could rewrite this as the integral of the double integral of 2x to the sixth, y to the third. Then we could flip the order of dx and dy. Since we're flipping the order of the integration, we would also have to flip where the upper and lower bounds are written. So in this case, it would be the interior integral would be from -2 to 4, and the outer integral would become from 0 to 1. So it doesn't matter what we integrate with respect to first, x or y, as long as we're keeping those upper and lower bounds associated with the right variable. But the easiest way to approach a problem like this would be to just take it as it's written and first identify that interior definite integral, which in this case is with respect to y, evaluated from 0 to 1. So what can be helpful is to just rewrite the problem. Again, we can pick out that any y part of the function that we'll be integrating with respect to. So what we've done is just gotten rid of that extra notation, and now we're just looking at what's more or less a relatively simple integral. Instead of a double integral, we have a single integral. We integrate with respect to y and treat everything else as just a constant multiple. So this will become 2x to the sixth, and then the integral of y to the third will be y to the fourth over 4. Or what we would get here is x to the sixth, y to the fourth over 4. And then we want to evaluate that excuse me, from y equals 0 to y equals 1. So again, we need to pay attention here that we integrated with respect to y, meaning it's the y variable that's changing from 0 to 1. So we're only going to make substitutions for the y variable. So this will become x to the sixth times 1 to the fourth, or times 1, over 4 minus x to the sixth times 0, excuse me, 0 over 4. So x to the sixth times 0, this part just becomes 0. So we get a final result here, well, not a final result, an intermediate result of x to the sixth over 4. Oh, actually, let me go back. Here we had 2 over 4. This should be over 2 in each case. I apologize for that. So over 2, over 2, over 2, because our 2 over 4 would reduce to a 2 in the denominator. So this is our intermediate result from evaluating this interior definite integral. So now the remaining part of the problem that we have to evaluate is the integral from -2 to 4 of whatever this expression came out to be, which is x to the sixth over 2 dx. So now we're integrating with respect to x. So if we want, we could highlight the variable portion to ourselves. But really what we're down to is a definite integral with only one variable. So this is exactly like previous integral problems that we've encountered. So the 1/2 is a constant multiple. We can set that aside and just integrate the x to the sixth, which will become x to the 7 over 7. Or x to the 7th over 14. Since we integrated with respect to x, then we want to evaluate this from x equals -2 to x equals 4, which will give us 4 to the 7th power over 14 minus negative 2 to the 7th power over 14, or a result of 8,256 over 7. So kind of a weird result there, but the basic process for this second integral is exactly the same as integral problems that we considered with just a single independent variable. So for these types of problems, work that interior integral first. When we get to this intermediate result, one way to check that everything has gone according to plan is whatever variable we integrated with respect to should be completely gone from this result. So originally we had a function in terms of x and y. We integrated with respect to y. The result is just in terms of x. So this intermediate result should get you down to just a single variable, and then our final result should get us down to just a number.